CloudDB, shaping your new normal.
Welcome everyone to the 2021 APEC Groundbreakers Virtual Tour by APACO UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. That way you'll be able to watch the replays or the playbacks later until December 30. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, we have 2 great speakers presenting this session today, Kwasi Mensah and Michael, the making of the Oracle R2DBC Driver and how to take your code from Synchronous to Reactive. Please feel free to write questions at any time during the session by using the chat tab of live webinar, and the speakers will be answering your questions as soon as possible. If there is any issues during the presentation, please feel free to contact me at any time by using the same live webinar chat. Now, without any more delays, I would like to leave you with this amazing session by Kwasi and Michael. I just open you guys' microphones, and you guys now have full control of the session.
Thank you, Francisco. Hello, everybody. Welcome to this wonderful session. I'm with Michael. Michael, you want to introduce yourself?
Hi, I'm Michael. I'm part of the Oracle JDBC team, and I'm the programmer for the Oracle R2DBC Driver.
Perfect. I'm the PM for everything we do for Java in the database organization. Next slide, please.
Okay.
Here's the agenda. We'll tell you how we get here, and then Michael will go into the making of the Oracle R2DBC driver, and then a bonus, but a good bonus, taking your synchronous Java code to reactive. So you will learn how to do that tonight or today. Next slide, please. So once upon a time, a very long time ago, 2017 is like a long time in our industry, right? Anyway, we started a project in 2017, and the name of the project was the Asynchronous Database Access API, or ADBA. And we had great ambition for this project. We wanted this API to be a standard database access API. And the main characteristics is the user thread, your thread, never blocks. Okay, so we use other threads in the back, but your user thread, so when you make a call, it returns immediately, never blocks, right? And the other characteristics is it's not a complement or a substitute for JDBC. It's a completely different programming model. It's a reactive programming model, right? And the reason to do that is because synchronous programming, until now, consume a lot of threads, OS thread, and those are very expensive in terms of scheduling, memory, CPU cycle. So that's why the community moved to the reactive programming, where you don't have a thread tied for the duration of a call to the database, right? So that's what's the motivation. The other motivation is that you can make simultaneous call to multiple resources. For example, you can invoke multiple databases simultaneously in your same application. You can do MapReduce, etc., etc. Or you can just make a stop proc call and forget, right? DML. Anyway, that was a beautiful and very well thought API. And you can see the code at the link at the bottom of the screen. Next slide, please. So you might ask, what happens to ADBA? Okay, so we stopped working on ADBA. Why? Well, for 2 main reasons. The first one is our own Java SE, the team within Oracle who directs the future of Java SE by working with the Java community, they told us the future of Java scalability is virtual thread. In other words, they are not looking for an asynchronous solution to address Java scalability. And that was what we were proposing. So we could not get the approval to make this API a standard. And without that, it was not worth our effort. So that was one of the main reasons why we dropped this project. The second reason was that the community, we did not get a strong support for the Java community. Yeah, we would love the Java community to say, yeah, we need that, we want that, blah, blah, blah. So we didn't get that. That's why we abandoned the project. The code is still there. Some people have forked the code. Anyway, we learned a lot and we moved on. So next slide. So we changed our focus towards JDBC Reactive Extension built into the driver that I will show you in the next slide. And then we also focus on the Oracle R2DBC driver. And you have the guy who wrote the driver here, you know, Michael wrote the R2DBC driver. So you can ask him any question you want. And by the way, he also wrote the reactive extension or part of it. Anyway, so we did that. We did the reactive extension in the driver built into the JDBC driver that I'll show you in a moment. We built the Oracle R2DBC driver, which is the main focus of today's presentation. And we also instrumented our JDBC driver to support virtual thread. Remember, virtual thread is the solution to Java scalability. That's what the Java SE team thinks. So next slide. And here is the JDBC Reactive Extension, which is built into the driver. And it is based on the Java Util Concurrent Flow API. So in that API, you have a publisher and a subscriber. And what you're seeing here are the APIs of the reactive extension. And you can see here that to get a connection, you know, to get a publisher, which is of the type Oracle connection, you will invoke build connection publisher Oracle. You invoke that method, it will return a publisher, and the subscriber will use that publisher and make some demand, you know, and that's the moment where we will seek a connection. So when you invoke the function, it returns immediately. Any function you see on this slide returns immediately. No function here blocks, right? And same thing, you can see that the SQL execution, they all return publisher, and you can see the similarity with JDBC calls. If you're familiar with JDBC, you know that you have the execute update, execute batch, and execute query. Similarly, we have execute async Oracle. So anytime you see async Oracle, this is our reactive extension, and we are doing the similarity, you know, with JDBC. So we put async, that's self-explanatory, and Oracle, because we don't want the future, if the community, the Java community decided to have a reactive extension to JDBC, we don't want to clash with that. So that's why we postfix with Oracle. So it's all good. And like row fetching, same thing, you know, you get a publisher and then you get a function. You need to have a mapping function that is applied to every row, right? And similarly, you can see that functions to read or write into lobs, and similarly closing and doing a transaction. Okay, so look at the Oracle JDBC driver documentation. Starting version 21, you need to be using the 21 release, 21.3 release. You will need to use OJDBC 11.jar, which is built using JDK 11. Okay, next slide. Here is the picture of what you can do with the reactive extension. You see the reactive extension in blue, right? You see the JDBC driver with the dotted line and red. You have the standard JDBC API in sort of gray. And at the bottom of the slide, you can see that you can still be using the JDBC API to make synchronous blocking JDBC calls. If you go a little bit higher in the middle, and you're just using the reactive extension, you can do asynchronous calls with non-blocking back pressure, which is the implementation of Java SE reactive stream interface. That's Flow. If you go a little bit higher, if you are using third-party reactive libraries, such as Reactor, RX Java, Vertex, Akka Streams, so you use those third-party libraries on top of our reactive extension. Now you get full-fledged reactive programming with operators, with concurrency modeling, monitoring, tracing, etc. So you have the high-level abstractions of reactive programming, whereas the reactive extension is sort of low-level, API that you can use yourself. So we give you a sort of complete solution, I would say, to do reactive programming, but that's not the whole story. So next slide. Okay, now I'm going to turn to Michael to give you the essential of today's call, which is the making of the reactive extension, and he will also walk you through the bonus. So I'm muting myself. Michael, go ahead.
Okay, so how do you make an R2DBC driver? For us, the journey kind of is going to go through a few layers. And the first layer where we start is in the JDBC driver. So what I've put on screen right now is these two methods, execute and execute async Oracle. This is kind of a mock-up of what we might do for the prepared statement class and doing asynchronous SQL execution. So the requirement for me, I had to program the reactive extensions at the JDBC layer, was to essentially translate the behavior of the existing synchronous code and translate that into asynchronous code. So we have these two methods. One returns a Boolean, and the Boolean is the result of a database call. And on the right, the asynchronous form of this publishes a Boolean, which is also the result of the same database call. And if you stare at these two bodies of code long enough, you kind of think, wait, they're almost the same. And you're not seeing double. That is, in fact, the case. The async code and the synchronous code actually share a lot in common. And I've kind of divided it up into three sections. And we see the blue section at the start. We see this green section at the bottom. And they are identical between the two implementations. So the blue code is all the stuff I'm going to do before I call the database. And the green code is all the stuff I'm going to do once I get a result back from the database. And the only point where these two implementations differ is right in the middle of, well, how exactly do you call the database? And on the left, with the synchronous code, we do a synchronous call. We go to our connection object, and we say execute the SQL, and it returns a SQL result. On the right side, where we're doing asynchronous programming, we're going to call execute SQL async, and this is going to return a publisher of a SQL result. And you'll see I'm using this flux.from. If you haven't seen that before, It's from a library called Project Reactor, which is an excellent tool if you want to do reactive programming, because what Project Reactor does with its Flux type, it allows you to take a publisher and use it a lot like a Java util stream. So now we have kind of a better abstraction to work with. We can think about a stream of values. And that's why on the next line, after I create my Flux, I can call map on it. And I can map a value, each value from the stream, into a different value. And in this case, we're mapping it into a Boolean, which we evaluate by seeing if there's a result set. We check if that's null. And return false if there is no row data, if there is no result set, or we return true if there is a result set. So one problem with this code, though, is we have a bunch of duplicate code. And this is never a good thing, right? Because someone's going to come along, they're going to make a fix in one method. Worst case scenario, they forget to change it in the other method. And then best case scenario, they're cursing my name because I'm making them repeat their work twice. So what we end up doing is moving all that common code into smaller isolated methods that can be shared between both the asynchronous and synchronous implementations. And this actually benefits the code in a way, because if we go back and we look at the original execute, there's kind of a lot going on here. And now we have a much smaller method, and it's a little easier to follow the flow of things. First, we're going to prepare for executing, then we actually do the execution, and then we do something with the result. So this kind of process is, you're seeing mock-up code, but this is exactly the kind of process I followed to implement reactive extensions for JDBC, was going through a lot of code that had been there for a long time and actually, in a sense, kind of cleaning it up. And then that was a bonus, was getting cleaner code, and we actually got the reactive code from that as well. So this kind of process goes all the way down the stack, right? Because we see it's not just one method. It's not like we call the database right here. We actually call another method. We call it the JDBC connections execute SQL method. And now we go down the stack, and we're going to break that next method down. And we do this all the way down the stack until finally on the right edge of the screen, you see eventually we get to a TCP network socket channel. And this is where we're really going to see a difference in behavior. Up until now, we've kind of just been setting up these publishers. So what Synchronous JDBC does is it goes to that socket channel. It writes this request over to the database saying, will you please execute this SQL for me? And what the Synchronous code does is it just sits at the end of that socket channel, and it blocks, and it waits for the database to come back with a response. And it just hangs on to your thread, and that thread can't do anything until the database responds back. And then we return up the stack, and we return to your code, which is calling JDBC. What the reactive extensions do, they go up to that socket channel, they write that request to the database, and then they say, okay, I'm done, and they walk away, and they return all the way back up the stack immediately to your code. They don't wait for the database. And they go to your code and they say, here's your thread back, go do something useful with it. And we also give you, though, in addition to giving you your thread back, we're also going to give you this publisher. And you can subscribe to your publisher, and that's how you can get your result back from the database. So we see that happening the very bottom row. This is representing an asynchronous thread of execution, running all these green result handling functions almost in a chain. And then at the end of the chain is your subscriber to our publisher, and we emit the result back to you. So there's no blocking of the thread here. That's the main takeaway. So that was the JDBC layer. And the next layer is going to be R2DBC. So originally in my mind, I thought, okay, this should be a pretty straightforward, simple mapping from R2DBC SPI to our Reactive Extensions API. And that mapping is kind of what I show on the screen here, where for R2DBC, we create connections with a connection factory that just maps over our connection builder, which is how we create connections for the reactive extensions. And the same for statement and execution, result, mapping row data into a different type. These all kind of map onto the reactive extensions. I put a link at the bottom. That's where you'll find all the R2DBC code. And if you go check it out, you'll see it's actually not as simple as I thought it would be. We've been working on it for a year now, and there's quite a lot going on there. It's all been kind of improving up upon what the foundation that the reactive extensions laid. We're doing all kinds of great things. So please check out our page and let us know what you think. And these are more wrappings. And essentially what you can take away from these slides is all the functionality offered by the reactive extensions is also being offered by R2DBC. And you can also think about it the other way. If maybe you prefer the reactive extensions, you're not missing out on anything by using those directly instead of R2DBC, other than having a standard API, which is really the main thing about R2DBC is it is a standard. It is implemented by not just us at Oracle, but by many, it is implemented for many different databases. But we all have the same API, or SPI. Okay, so we've seen the JDBC layer. We've seen a bit about the R2DBC layer. And there's one layer left, and that is your layer. That is your code. Because in order to use all this wonderful non-blocking reactive code, to put it to good use, you need to make your code reactive too. Because one thing you should never, ever, ever do is go to R2DBC or go to JDBC and say, create this publisher for me and go do everything non-blocking. And then what I'm going to do is I'm just going to block and wait for that publisher to come back with a result. Now you're just blocking a thread again. And in fact, you've spawned another thread in the background. So never ever block with a publisher. You want to write reactive code to make use of this. So the rest of this presentation, I'm going to go through quite a few code examples. And what we're going to see is, again, this split vision. Left side is going to be synchronous JDBC code. And then on the right side, we're going to see how to do the exact same thing using R2DBC. So the very first thing we want to do is we need to connect to our database. And so we're just showing on this first slide how you might configure JDBC with your host and your port and your service name, and of course, use your password. And then we see the equivalent code on the right side with R2DBC using this nice builder API to create our configuration, but we're doing the same thing. Okay, so now we have a connection. Let's go run some SQL. For the synchronous code on the left, we create a statement with our connection, and we give it the SQL we want to execute. And then we move through the rows that result from that SQL with our result set and invoking next on the result set. And when we want to get an individual column value from each row, we call a method like getString, and we give it the index of the column. In JDBC, the first column has index 1. It's not 0, which a lot of us might be used to. And then also we can do something like say, well, if there is no row, if result set returns false, then I'm going to throw an error back at whoever's calling me. I'm going to throw this no such element exception. So the same behavior, same database interaction. We accomplish that on the right side with R2DBC, again creating a statement and providing the SQL we want to run. And then by executing it, we have a publisher returned when we call execute. And we can use Project Reactor, and we can use the flux type to kind of operate on this stream like it is a Java util stream. And we're going to use this flat map operator. And we're going to operate on this result object. And with the result, we can say we want to map each row into a particular kind of value. And we can extract that value from the row. We extract the value of a particular column by calling the get method on our row. And in this case, we're specifying that we want the string type when that column is converted back to you. And it's using a 0-based index. But it is essentially doing the same thing as calling result set get string. And we also have a switch if empty operator, which functions like that else case where result set return false. And we can emit a stream that is a no such element exception error. So one thing I've done in the bottom right is I've used this notation because I want to make sure we all understand flat map before we continue, because flat map is very, very important. Flat map is maybe, if you need to learn one thing to use reactive streams, you should learn flat map. So what flat mapping is saying I can have a function f that takes as input a value x. And given an input of x, the function outputs many values. It outputs a stream of y values. And when we flat map, remember, we're working with a stream of values. So we flat map a stream of x values by applying that f function on each value x in that stream. And we know that the output of our function is a stream of y values. And so when we flat map a stream of x values, we concatenate all the y values that are output by applying our flat mapping function to each x value. And we end up with this sort of flattened, contiguous stream of y values. I hope that explanation helps, but make sure you understand that if you want to start using stuff like Reactor. Okay, so this next example is just doing an insert. We're going to insert a row into a table. And with JDBC, we call the setters. We say set string, and we say execute update, and this returns an integer update count. Same database interaction with R2DBC on the right side is calling bind to specify the kind of value we want to set at these question mark parameter holders, and calling execute to get that result object. And then in this case, we're flat mapping just into an update count. We can, from a result object, we can request the number of rows that were updated by the SQL we've executed. So now we're just flat mapping into a publisher of an integer. And that's why you can see the return type for this insert R2DBC method is a publisher of integer. This is very similar to the one I just showed. It's now doing an update. We're going to bind values. We're going to execute our statement. And then we're going to get the update count. Okay, so the remaining examples are where I think this gets interesting. Because now what I'm going to show you is all the synchronous code. It's going to do a blocking database call. And then based on the result of that call, it's going to do something else. So we have a flow of control here. We have call JDBC, get the value, and then you can see I'm doing an if else. And depending if my update count's 0, I do one thing, and then if it's not 0, I do something else. So what we're actually doing in this, what we're trying to accomplish with this code on the left side is saying, I want to update a row in the database. And if that row doesn't exist, I'm going to get back an update count of 0 because no row was updated. So if I get that result, well, then I want to create the row. So then I'm going to do an insert. So that's why we say, if my update count is 0, then return the result of inserting. And then if it's non-0, just return that value. So how do we do that with reactive and asynchronous code? Because we don't want to say with R2DBC, go do this update and then wait for a result by blocking and then going to an if else, because now we're blocking a thread. And I said we should not do that. So what we do instead is we're using a flat map operator. That's why I said it's very important to understand that. We say, do this update with R2DBC. And then based on the result we get from that, we're going to process that with a flat mapping function. So this is going to happen asynchronously. This is going to happen after we get a result back. And we're going to flat map into one of two possibilities. One possibility is if we get that update count as 0, well, now I'm going to flat map into my insert publisher. But if I get an update count of non-0, well, now I'm just going to flat map into this flux just, which is just kind of self-explanatory. It's a stream of just this value. So in this way, I'm able to kind of do that conditional logic based on a result that I'm receiving asynchronously. This next example is doing an insert. Oh, we need to note one thing about this code. If two threads were to execute this code at the same time, it might be the case that they both see an update count as 0 and they both try to insert at the same time. And what the database will do then is throw an error at one of them. Because if two concurrent sessions are trying to insert the same row, and we're good SQL programmers, so we have a primary key column, the databases say you can't do that. You have to have a unique primary key value. So we're going to note that about this code. It will fail if run concurrently. So now in this next example, I'm sort of trying to compensate for that. And I'm saying, okay, well, I think I know what to do. So we can look at the left side and we say, let me try to do an insert. And if it succeeds, great, I'll return the result. But if it fails, I'm going to go into my catch block. And I'm going to look at the error code. And if I see it's a unique constraint, well, now I know the row already exists. So now I just need to go do the update. So we're going to try the insert first and then do the update. And then if we don't recognize the error code, now we just throw the SQL exception because we don't know how to recover from that. So here's another kind of flow of control of a try and a catch block, and deciding what do we do next based on what happens in the catch block, which is the result of a database call. To accomplish the same thing with R2DBC, we create a publisher of the insert, and then we use this on-error resume operator, which is going to function like a catch block. And we're saying, here's the type of error I want to catch or resume upon, which is the R2DBC exception, which if you know SQL exception, you know what an R2DBC exception does. The APIs are very similar. In this case, we can see they both have a get error code, which allows us to figure out why is the database raising this error at me. And we can do the same thing. We can decide to either update if we see the row already exists, given by a unique constraint being violated, or we can just publish the error if we don't really know how to recover from it. So we can note that this on-error resume is functioning a lot like a flat map. It is a function that takes a value as input and outputs another stream. In this case, we either output the stream of the update count, or we output a stream of the error. We can note too that this code also has a problem though, which is it might be possible that maybe another session comes in while all this is happening and it just deletes the row. And then in that case, this update might actually return 0 because the row has been deleted. So our insert failed because the row existed, and then it was deleted, and then we tried to update it, and now the row is gone. So now for the final example, we're going to try to address all these problems we've seen. And the way we're going to do it on the left side with JDBC is using a do-while loop. So what the loop is going to do is it's first going to try the update, which we saw back here, which we noted results in an error if run concurrently. So it's going to try running that, and then if it catches that unique constraint violation, it's just going to kind of ignore it. Note in this case, our if is a not equals. So if it's not this, well, now I'm going to throw, I don't know what to do with that. But if it is unique constraint, okay, I'll just go around for another iteration of the loop. How on earth do you replicate that using asynchronous code? This for me was one of the hardest problems to solve when I was learning reactive, because you can't just like within a do while loop, create a publisher and then like block for the result to figure out, like, do I go around for another iteration or do I have the result I want? This perplexed me for a while, and finally figured it out. The solution is I think it qualifies as recursive, although it's not recursive as we're used to. Usually when we do recursion, we have a method calling itself and it's all happening on one thread. And if we do it too many times, the stack overflows. This is a callback that calls the method that initiated the asynchronous operation. Let me explain what I mean. So on the right side, we have our try update publisher with R2DBC, and we're using on error resume to see what kind of result we get back, and then essentially flat map into another publisher. So here's the recursion. If I get the unique constraint violation, I'm going to call the method you see on the screen. I'm going to call R2DBC. I'm going to flat map. I'm going to call loop R2DBC, and I'm going to flat map into the publisher returned by that. And so in this way, we have the result of an asynchronous operation sort of going around for another iteration. We look at this result, and then we decide if we go again for another iteration in this loop. I do want to mention, I know I had to go through a lot of these quickly. All these code examples are up here on GitHub, Oracle R2DBC. It's in the samples directory. So you can check them out on there. And I left lots of Java docs, and I explained what's going on with all these. Okay, so that's how you make R2DBC. So for Quasi, do you want to wrap up?
Yes, I can wrap up. So Michael, you need to you need to mute yourself.
Sorry, let me do that.
Okay, so to wrap up, remember this slide was shown in part 1. We did not have R2DBC at the time, and we were only using third-party reactive streams. Remember the green box? On the green box, in the part 1 of this slide, we did not have R2DBC. Now we have R2DBC as well in the green box. So what it means is you have all the choices. You know, you can use synchronous blocking JDBC calls at the bottom, or you can use asynchronous call with non-blocking back pressure using just the reactive extension, the blue box. Or you can use any third-party libraries you love in the green box, or you can use the R2DBC, which is the de facto open source standard that every database vendor is implementing, as Michael explained. So you have all the choices, and JDBC is ready. And Michael can add one last thing. Michael, if you want to comment on the instrumentation to support virtual thread.
Yes, so if you're willing to wait, in the future release of JDK, of Java, we should have a nice lightweight thread. And I've done some testing because they have an early access build. And if you use synchronous JDBC on a virtual thread, you can get very, very close. For me, the reactive code is still a little faster. And we're talking at a large scale here. We're talking, you know, hundreds of concurrent database calls, maybe on one core. We see virtual threads perform almost as well as the reactive code. And Oracle JDBC is all set to go for virtual threads. We've made, because there are some changes. You should, if you're using a library that's super critical and you want it to be virtual thread ready, you should check with the library authors and make sure they've done all the changes they need to be compatible with virtual threads. So Oracle JDBC is ready to go for virtual threads whenever they arrive.
Thank you, Michael. So here you go. We give you every option. Now it's your turn. So whatever you want to do, we are ready. Okay, we have no question on the chat, Francisco. We're done with our content.
Fantastic, Kwasi. Thank you so much, Kwasi and Michael. Another amazing session from you guys. Thank you so much. Excellent content, like always. It's always a pleasure and an honor to have you guys with us. Thank you so much for sharing your experience, your knowledge, and with the community in the APAC and all around the world. And as we don't have questions, I was just checking right here again. No. If anyone has any questions watching the playbacks that will be available until the December 30th through the platform, please feel free to contact Kwasi and Michael directly by their emails or via Twitter. And if you cannot reach them, please feel free to reach myself, Francisco, and by Twitter, or the APAC, anyone from APAC IUC, the community, or through the platform too, and we will relay your questions to Kwasi and Michael. Saying that, thank you so much, guys, and please have a wonderful day, night, depending where you guys are around the world, and take care and be safe. Thank you so much. Have a wonderful weekend.
Thank you. Bye.
Bye-bye.
CloudDB, shaping your new normal.